Hey everyone, we're going to find the critical numbers of the function f of theta equals 2 cosine theta plus sine squared theta. All right, so we're going to find a number c in the domain such that f prime of c equals 0 or f prime of z does not exist. This part's not going to happen with this. So we just have to worry about the first part. So we're going to take f prime of theta and take the derivative of 2 cosine of theta, which gives you negative 2 sine of theta. And then sine squared of theta, that's going to be your double angle, 2 sine of theta, cosine of theta. Now to help us solve this, let's factor out 2 sine of theta. And to save time, if I factor it out of this piece, I get cosine of theta. If I factor it out of this piece, I get negative 1. It just looks better that way. So now we want to set f prime of theta equals 0. So we have 2 sine of theta equals 0. So that would be sine of theta equals 0. And for this piece, we have cosine theta minus 1 equals 0, or cosine theta equals 1. So we have it at 0 and at 1, which on the unit circle, that happens here at 0, pi, then go around to 2 pi, then you keep going around and around. So every time you go around, it's going to happen. So what we're going to say is our critical values are theta equals sum n times pi. So our n is an integer. So that would be starting, let's start with 0. So if n is 0, we get theta equals 0. And that would be correct for sine. And if n equals 1, we get theta equals pi. Oh, this would be correct. So if n equals 2, you get theta equals 2 pi. So it keeps going around and around it's the periodic properties of trigonometry. So this is your final answer. And that's it. Thank you. Have a nice day. Bye-bye.